Okay, so in this problem, we want to verify the identity tangent squared x plus 1 times the quantity cosine squared x minus 1. We want to show that that's equal to tangent squared x. And when you're verifying trig identities, you want to start with the more complicated side and show that it equals the less complicated side. So I'm going to jot down negative tangent squared x down here in the corner to remind me of where I'm headed. And I'm going to use this left-hand side as the more complicated side. That's going to be my given information that I start with. Okay, then I'm going to make myself the Trig Identity Hexagon to recall those fundamental identities that are so useful when verifying larger identities. So we start with tangent here on the left corner and then use the quotient. So tangent is the quotient of sine over cosine. And then we'll fill in the diagonals with reciprocal identities. So cosine is the reciprocal of secant, sine's reciprocal is cosecant, tangent and cotangent are reciprocals, and then we always put a 1 here in there. And whenever you see squares, like in this tangent squared x and in this cosine squared x, that should be a big bell going off in your head that you want a Pythagorean identity. And if you recall, those Pythagorean identities are found in these three triangles on the hexagon. So this triangle here, sine squared plus cosine squared equals 1 is identities. Okay, and that looks very much like this cosine squared x minus 1. If I wanted to replace that cos squared x here, I would subtract sine squared x from both sides, and cosine squared x would be equal to 1 minus sine squared x. So now I replace that cosine squared x in the original using a Pythagorean identity. Similarly, this tangent squared x is part of an identity. Tangent squared x plus 1 is equal to secant squared x. So we'll jot that one down. Tangent squared x plus 1 equals secant squared x. And that means if I notice this whole part here, this tangent squared plus 1, that means I can replace that with secant squared x using a Pythagorean identity as well. So we're going to go ahead and in our next step, we're going to replace that tangent squared x plus 1 with secant squared x using that Pythagorean identity that we just looked at right here. And then this cosine squared x, we're going to replace that with 1 minus sine squared x. And then that's also got a minus 1 after it. And our reason for step number 2 is that we applied a Pythagorean identity. Okay, now we're going to go ahead and simplify. So 1 minus sine squared x minus 1, that 1 minus 1, those like terms cancel, and we'd be left with secant squared x times negative sine squared x. And that was combining like terms. And then when we multiply these together, that negative can come out to the front. So we'll have a negative sine squared x times secant squared x. And we also, we multiplied and then we used the commutative property for multiplication there to get that sine squared x in the front. Okay, now if we look back at that identities hexagon again, sine is right here and secant is right here. And if you recall, the product identities take the vertex to the left and the right and they meet at the product. So the product of sine and secant is tangent. And we've got the product of sine and secant here. So we can apply that product identity to rewrite this as negative tangent squared x. That was using a product identity. And we've done it, right? We wanted to get that to match down here in the corner, negative tangent squared x, and we got that exact result. So now we have shown, using fundamental trig identities and a little bit of algebra, that tangent squared x plus 1, that quantity times the quantity cosine squared x minus 1, that is in fact equivalent to negative tangent squared x. And so our identity has been verified.